Hello, everyone, and welcome to our Coast Talk for May 2023. Today's talk's on decarbonising shipping, the green future of blue transport. My name's Jason Goldsworthy. I'm the Executive Director for Coast, and I will be today's host and moderator for the session. I'm speaking to you today from the Lekwungen speaking people, now known as the Songhees and the Esquimalt Nations, and I'm very grateful for that privilege. For those of you who don't know about Coast, Coast is the Pacific hub for the sustainable blue economy. We're driving innovation in the ocean technology and marine sector in BC. We're supporting new startups and existing companies wanting to scale up or get new technologies to market. Today's topic is the discussion will be regarding how to shift to net zero in shipping. We're looking at what role the new technologies can play in achieving those goals. Those goals are fairly lofty, and I'll let some of our speakers talk about those today. More importantly, how do we get these new technologies to market and adopted? And what are some of the barriers that are preventing us to get there? We're very privileged to have three dedicated people tackling this issue to talk to you today. We've got Elisabeth Charmley, who's the co-founder of the Vancouver Maritime Centre for Climate, Alistair Johnson, who's Dasivedo, sorry, Alistair, I got there, and Chris Mulder, the president of Capilano Maritime. First up to chat with us it will be Elisabeth Charmley. Elisabeth is a professional engineer with over 20 years of experience. She's got experience in both Canada and international deep sea shipping and transportation. She's a maritime decarbonisation expert, which makes her perfect for today's discussion. She spent 10 years with Seaspan. I'll get there, Elisabeth. And in 2020, she co-founded the not-for-profit Vancouver Maritime Centre for Climate. She's been on the Innovation Advisory Council, looking at a BC-wide shipbuilding strategy. She's the Vice President for the Women's International Shipping and Transportation Association, and she's an advisory board member for the tech startup VaultSafe. I'm tired just listening to what you do, Elisabeth. I don't know how you do it. So I'd like to hand it over to Elisabeth, and she'll have a time to chat, and then we'll introduce our other guests as we finish up there. Thanks, Elisabeth.
Thank you so much, Jason. That was wonderful. I know it's a lot, but I think you handled it well. It's a real pleasure to be here today at this Coast Talk. Coast is an absolutely great organization, and I'm really glad to be here this morning. As Jason said, my name is Elisabeth Charmley. I'm co-founder, executive director, and chair of the board of the Vancouver Maritime Centre for Climate. If you're not familiar with the VMCC, we are a grassroots industry-led organization dedicated to accelerating the transition to a zero-emissions shipping industry in the province of British Columbia. Currently, we're a coalition of over 60 members, and we work with those who are operating assets on the water and 1 degree removed in supporting them, as well as the myriad of supply chain activities that support those operating on the water and 1 degree removed through our membership. Our members consist of regional ship owners, basically the domestic captive fleet, deep sea ship owners, which are those operating on a global scale, terminal operators, port authorities, academia, governments, both provincial, federal, and local, innovators and OEMs, regulatory bodies and classification societies, and industry associations. Now it's my turn to be a bit tongue-tied, but basically everybody we need around the table to make decarbonization happen. And the VMCC itself acts as a hub for resources, a convening point for knowledge and information sharing. We provide communication services to our members, and we also facilitate opportunities for pilot projects and commercialization and technology implementation through our program, the Operation Flagship. And this program actively works to pair site hosts with innovators to trial or just implement clean technologies. All of this work is governed by our green shipping strategy, and this strategy is a collective strategy that guides and coordinates efforts towards zero emissions shipping industry here in our province. The goals within the strategy are aligned with provincial and federal targets, and we have implementation pathways in the strategy as well that guide specifically what we need to do. So when we made this strategy, we went out to industry and asked basically, what do you need to get to zero? And they said, well, we need zero and low carbon fuels. We need marine electrification. There's a focus on port operations as well, especially with green shipping corridors. So like ports of the future, zero emissions ports. We also focus on vessel energy efficiency as well. Industry indicated that they want opportunities to adopt emissions abatement technology. As part of these implementation pathways, we've identified key action areas that will help us along the path to get to zero. And we know that each of those need a little bit of research and development. We need to trial new technology through the pilot projects and commercialization. Everything's going to need help in the policy and regulation area. And of course, we can't do any of this without money. So we need green financing. We do this work through our steering committee and our work groups, both of which meet monthly to advance this progress. And if this sounds of interest to you and you're interested in joining, there are ways you can engage with us in the short term. You can head to our website, or we're having our 2-year anniversary party this Thursday, and you're more than welcome to join.
Thanks, Elisabeth. I'm actually really looking forward to the anniversary party on Thursday and actually meeting you in person finally. But I think it's a great organisation, and it's one where we at Coast here are looking forward to working closely with you. And it's such a great goal to have. And I think, we're very happy to be part of this ecosystem, and looking forward to working really closely with your team coming up. Next up, we have Alistair Johnson. Alistair Johnson is the founder of Dasivedo. I practiced this so much, Alistair, and I still got it wrong. Alistair, the best thing I can say about Alistair, first of all, he's talking to us from the UK, so I appreciate his dedication on that. But his experience is very diverse. He has a degree in anthropology. He's worked a lot in TV and film. He also took over the family scaffolding business, which I think he involved a little bit into the marine sector for that one. But in 2010, he started the design of the TIG rig retrofit sail system, which is really cool, especially for someone like me who's a sailor by heart. Effectively, it's wind-assisted shipping and putting sails on large ships. He completed that design in 2018. He's awarded a patent, US patent in 2022, and he's already received awards for the design from China and Japan, and as he was saying, more to come, hopefully. This is really interesting technology, and I'll let Alistair talk to you a little bit more about it, but it's something I had never thought about, but it's something that could really help in the future. Alistair, over to you.
Thank you very much. It's interesting. The other person with a degree in anthropology is Elisabeth, of course. So that's why we got on so well. Can you hear me?
Yep, we've got you, Alistair. Thank you.
Okay, I'm trying to share my screen. Mena, can you tell me what I have to press?
Yep, I'm just making, yep, you should be able to share your screen now.
Okay. Here we go. Right. Okay, I'm going to rush through this. My name is Alistair Johnson. I'm going to present an overview of Wind Assist, and then I'm going to show you my own technology, and then hopefully get room for questions. So, carbon is bust. The challenge is that no other existing or near horizon technology has the energy density or leverage of fossil fuels. So in order to solve that problem, we're going to have a large scale adoption of basket of technologies, typically alternative fuels, that's combustibles, methanol, LNG, hydrogen, wood pellets, etc., and a few non-combustibles, nuclear or batteries, and then of course the natural ones, hydro, wind, tide and wave. The ships are going to be carrying this basket of technologies on board, and there'll be onboard energy markets. Ships have access to a unique, almost unique access to a power source which is delivered free at the point of use, which is wind power. And the only cost of this technology is invested in the capture devices, the sails, which is a huge advantage over combustible technology. Wind assist, the wind power is unpredictable through the voyage, and wind assist requires slow steaming of the vessels. Currently, retrofits are delivering 4 to 8%. That'll increase with R&D to probably 10 to 15%, and new builds will deliver 20 to 25% of capacity, power capacity thrust. But the reality is that we're not going to replace the fleet for 30 years, and so retrofit is going to be a major issue. Combustibles will start to increase above inflation in cost as the fuel crisis bites. At the same time, with increased R&D and mass production, the unit cost of wind assist will fall by up to 66%. That means that wind assist will be deflating while combustibles inflate. So wind assist is on that basis a no-brainer. It's also important to say that it is a highly visible statement of intent to consumers and voters. The IWSA, International Windship Association, is the advocacy body for wind assist, and Gavin Allwright is the General Secretary. The IWSA became a consulting member of the International Maritime Organization in January 2022. Gavin produced a very good paper in March 2021 calling for a level playing field and an assessment of the full carbon life cycle of each alternative power technology. And in April 23, he produced what is a very optimistic and encouraging discussion of what he thinks is the shipping, what is going to become the tipping point for wind assist. Here is my technology.
Hello, my name is Alistair Johnson. I'm an English-born Canadian based in Vancouver, and I've devised a way of retrofitting sails to the world's merchant fleet. That is flat deck ships like the one behind me. And I put the self-contained sail.
Oh, sorry.
The units around the side of the hull. And, I put the self-contained sail units on mounting points around the side of the hull, and the mounting points are interconnected by rails, so that in port you can wheel the units around from one side of the ship to the other, so you have unobstructed access to regular dockside operations. This TIG-rig retrofit sail system is protected by international patent, and offers the opportunity for other master devices to be mounted on the same mounting. So what I'm going to be doing is offering the other designers of mounted devices an opportunity to come in with me on the mounting system, so that whichever of the different devices works the best and is most successful, everybody will get something out of the mounting system. The TIG-rig can save between 4 and 8% in fuel at 12 knots, and if you reduce the speed of the ship to 11 knots, the savings go from 5 knots to 11%. These are quite good numbers. If we were able to fit TIG-rigs to the entire merchant fleet, all 40,000 flat deck ships, and do savings of 4 to 8%. I mean, if Germany was to announce that we're going to reduce greenhouse gas emissions by 4 to 8% in a single year, that would be huge news. So that technology is currently available, but the shipping industry is not taking it up fast enough. The International Maritime Organization has demanded that the shipping industry reduce its emissions by 50% by 2050. In response to that, NES, which is the biggest fleet in the world, has promised to reduce its emissions by 100% by 2050. Well, nobody knows how that's going to be done, but that is the target that's been set. And it's similar in a way to President Kennedy announcing that the United States was going to take someone to the moon. Now, nobody knew then how the Apollo mission was going to achieve that goal, but it did. And in the process, it invented the first mini computer. So we don't know exactly what technology will be employed to achieve these savings, but part of it will be wind-assisted devices, and part of it will be retrofitted wind-assisted devices, and that's where the TIG-rig comes in. CERN was the other great collaborative project which announced the particle accelerator in Switzerland, and that was an international collaboration. And like the Apollo mission, it required a total disruption of normal business practice or institutional practice. And collaborative disruption is what's going to be required to combat this climate issue in shipping.
So I hold patents in US, China, and Japan, with Canada, Europe, and India to come. I don't have an award from anybody yet, but thank you very much, Jason, for thinking of me in that way. The mounting is a second generation technology, and it's very difficult to predict when that's going to kick off. So we've pivoted to two cheaper or lower cost entry products. One is a log raft, which we're going to be fixing to log rafts on the one-way trips from the mouths of the different rivers down to the processing plants in the lower mainland. So you'll save fuel, reduce marine noise, help steering and stopping, and therefore improve safety. And the controls that we'll develop, the algorithms from the smart box, which we'll use to control those, will go forward to the TIG-rig proper. The killer application, we're not sure whether it's going to be worth pursuing, but it would offer wind assist to container vessels, which at the moment are a no-go zone for wind assist. So that's us. Any questions?
Thanks, Alistair. We'll leave the questions for potentially after, where I can share them out with everyone, but appreciate their time. Sorry about the awards thing. I'd like to give you an award.
Thank you.
I'm not so sure what sort of award it will be, but hey, we'll work on that one.
There you go.
But very, thank you for your presentation. Finally up, but not least, is Chris Mulder. Chris is a professional engineer. He's got an undergraduate degree in mechanical engineering from UBC and a master's degree in marine technology from the University of Newcastle on Tyne. Very UK sort of thing going on here at the moment. He's been involved in the marine industry since 1988. And part of that was a graduate program in the offshore oil and gas sectors in the early 1990s, where saw him in Scotland, Netherlands, and Newfoundland. So very international. He's got 13 years of design experience with Robert Allen, and is currently the president of Capilano Maritime, who have just recently been a recipient of Clean BC funding for the first hydrogen-powered vessel in Canada. And I think Chris is going to give us a little bit of an introduction to that hydrogen solution. Welcome, Chris.
Thank you, Jason, and thank you for having me on Coast Talks. Pleasure to be here and talk about solutions for the marine industry. So as Jason explained, I'm Chris Mulder, president of Capilano Maritime Design. We're a naval architect firm based in North Vancouver, British Columbia. We design vessels of all types, and we work in the conventional marine industry, existing marine industry, as well as we are looking at one of our roles is looking at next generation technology for zero emission vessels. And for that, we have started a consortium which we call H2 Ocean. And if I could ask you to bring up my slide, that would be great. Yes. So H2 Ocean, it's a pilot project for the introduction of hydrogen as a marine fuel. Hydrogen is not going to be the solution for all vessels, but it will play a role as a zero emission technology that will work well for certain applications. It's going to be best suited for working vessels that are close to the harbor, such as harbor tugs, short-run ferries, crew boats, and harbor cruise vessels. And that is what our pilot project, the H2 Ocean, is, a harbor cruise vessel. It's and so just to give a little explanation about it, well, actually, first I'll start with the H2 Ocean Consortium. So Capilano Maritime is the lead partner in our consortium, and we've got we're partnered with H-Tech, which is the hydrogen supply and engineering company also based in Vancouver. Ballard, another Vancouver company that is the manufacturer of the fuel cells. And then our electrical integration partner is Canal Marine. And we have Lloyd's Register, which is a classification society, and helping us through the regulatory approval process to bring hydrogen on board as a marine fuel. And then we also have support from the Canadian Hydrogen Fuel Cell Association, as well as the University of British Columbia and Fairweather Cruises. So H2 Ocean is a catamaran design, aluminum boat, and it's as I explained, it's propelled by hydrogen fuel cells. So there's compressed hydrogen in conventional off-the-shelf tanks for high pressure, and which you can see as the blue tubes on the top deck. And directly in front of that are the two fuel cells. And then they provide electricity to the electric motors down in the hull. And so that that's the gist of it. All the hydrogen elements are concentrated on the top deck, and then all the electrical elements are down in the hull. So it's the one advantage that where hydrogen will have. So there's for the application of a zero emission on a ship. There's essentially two options, or perhaps three, Alistair. But for a powered vessel, there's two options. It could be a battery electric or hydrogen fuel cell, and they each have their strong points. And so that's why I'm saying it won't be the solution for all, but it'll have its place. The advantages with the hydrogen fuel cell application compared to batteries is you can put a longer range system on board the vessel because it's powered, or energy to weight ratio is much better than batteries. So like, for example, this vessel here can as a harbor cruise vessel, it could operate for 2 to 3 days on one supply of hydrogen, whereas a battery electric vessel would have to be recharging every 4 hours and then have a couple of hours of recharging. So that's the one advantage, and why it would be a good solution for hardworking vessels in the harbor. And I could just give a little more information on the H2Ocean. It's a 24-meter vessel, would carry 95 passengers in a seated dinner cruise application, or up to 194 in a cocktail setting. There's a crew of approximately 4 to 6. That crewing is yet to be determined, but it's conventional. It'll be the crew will depend on the catering requirements, but all will have to be certified for vessel operation and hydrogen systems. Has a maximum speed of 12 knots, but would most likely spend most of its time cruising 9 knots and below. There's 400 kilowatts of fuel cell power, which is 2 Ballard fuel cells, which is their FC wave. And that's the basic statistics on the boat. And the idea of this project is that it will serve as a pilot project, and the same technology could be applied to multiple different types of vessels. Okay, well, thank you very much. I'm happy to hear some questions later on.
Thanks, Chris. Appreciate your time there, and it's hydrogen vessels are very interesting. It's a technology I think we're maybe underutilizing a lot is the hydrogen use. So I'll get everyone to put their cameras on. You already have, thank you, and I encourage everyone from the audience. I know we've got quite a few participants in the audience. Please send through some questions for our panelists. I'm going to try and kick it off, but if you use the question and answer button at the bottom of the screen, you should be able to throw them into there, and I'll direct them as best I can to our panelists. All right, I'm going to actually start with you, Chris, if that's all right. As I mentioned, the hydrogen vessels, I think it's probably the closest we kind of have to direct replacing what we, you mentioned battery electric, and that sort of technology has some limitations, but hydrogen is easy, quick to refuel, all of those components, but it does going to take a lot of other infrastructure to fueling. And I think we've seen the similar with battery electric as well. So I know you said one of your partners is, I forgot the name of the company there, but they're actually involved in that sort of the shore side of things. How much How much investment is going into that to make sure that we have infrastructure to support the hydrogen vessel?
Yeah. So you're right. The infrastructure is key for just about any of these new technologies, and certainly for hydrogen. So it's a step-by-step process to increase improve and build the infrastructure. So there are things in motion, and it's starting on the land. As you may know, we have hydrogen fueling stations around the Lower Mainland for road vehicles. And so there's one here in North Vancouver. There's a couple in Vancouver and Burnaby and Victoria. And so H-Tech is the name of the company that is our partner, and they've been instrumental in leading the Canadian hydrogen industry in this area. And so for and they are also in the process of developing a large plant in North Vancouver for production of up to 12 tons a day of hydrogen. And so that's a very exciting project. For this first application, we're looking at keeping it as simple as possible. As I said, this is a pilot project. So we're going to implement the same process that the existing hydrogen fueling stations are refueled. So there'll be a truck with compressed hydrogen on board. It'll drive close to the vessel, and then high pressure hoses and pipes will transfer the fuel from the truck to the vessel. And it's just, it's purely a difference in pressure. So the truck has very high pressure hydrogen, and then the boat has slightly less high pressure hydrogen on board. And compressed hydrogen is the simpler solution at this stage. It doesn't have the complications of cryogenic liquid hydrogen. So let's prove the principle first. Let's get it going, and then we can work on additional projects after that.
It seems like the timing seems to be right, though, because all that land infrastructure is starting to come about in Vancouver. So it makes a perfect sense, or BC region and different areas. So I think that it feels like the timing just fits in perfectly to move towards a hydrogen vessel.
Yes, yeah, it does seem to be very, very popular right now. That there's a lot happening in the hydrogen sector. So we're looking forward to getting going on this.
Perfect, thank you, Alistair. The sales thing's a great concept. I love it. As I said before, I'm a sailor, so it's a really an interesting topic. I presume there would be some other technologies that could assist the wind assist. I'm thinking rerouting shipping. Is that something that could be considered in terms of making the wind assist even more efficient and easy to adopt? Oops, sorry, you're on mute there, Alistair.
Sorry, routing analysis will become more important. At the moment, ships tend to avoid the center of storms. They may want to be flying slightly closer in to get more wind, but you've got to bear in mind that we're only talking about, at this stage, 4 to 8%. So you may not be gaining enough to make it worth getting too close to the center. These are going to be very pragmatic decisions by the ship's masters.
I think there could be some opportunity there for linking it up. I mean, I know we've talked in previous Coast Talks about AI and, that sort of learning about routing, and maybe there's some opportunity there with better forecasting as well. So there could be a linkage between,
I mean, I was introduced to Elisabeth by a guy at Napa who are wind and tide specialists. So that's where I was looking, and that was so I've known that this was going to be a big deal right from the beginning. But it's extraordinary how much you learn and how ignorant you are when you start. And if I'd have known any more about shipping, I probably would never have started at all. But here we are. That's how it is.
And there's actually some ships already fitted with this technology as well, isn't there? Or the similar technology. So I think last time I read that,
we have 50 ships at the moment, and there were 25 ships this time last year. So, but 50 ships out of 40,000, 50,000, we're talking about 0.1% penetration. So it's really in its embryonic rather than even in its infancy. So it's got a lot of catching up to do, and if we doubled every year, we'd only be at 12% by 2030. So something's going to have to really shift quite quickly for it to pick up at the pace that's going to be needed, because wind assist is going to have to be on every ship, basically.
Well, that's a perfect segue into my question for Elisabeth. There's obviously lots of good things happening. There's some interesting technologies. We've heard about 2 great technologies today. Where do we sit in terms of how leading the industry, and how do we fit? What are others doing internationally in this space, and how can, I guess, BC accelerate to be better and lead the direction?
Yeah, for sure. No, I mean, I feel like I have some questions back for Alistair and Chris based on their talks as well. But yeah, I would be interested to know regarding the wind assist for Alistair, if he sees that a particular sector of the shipping market wants to uptake that type of technology. Because I would think that the wind assist technology would be relevant for certain types of transporters. And I'm just wondering if you see that in any of your discussions for your technology.
Well, the primary routes are the North Atlantic and North Pacific. So if you're regularly going across there, then this is the best. The 8% figures are on those prime routes, the wind routes. Yeah. That's the average east and west. So I mean, it's 16% one way going with the wind, you get an awful lot basically, and you don't get so much the other way. But the average is 8%. So it's but that's quite a significant figure. The problem that we have is that we're offering technology across a paradigm shift. And this is making it very difficult. Business decisions are difficult in any event, and investing across a paradigm shift is really, really scary. And that's the problem that we have. And there will be a tipping point, but we're not there yet.
Yeah. And then I'm wondering, for Chris, if you see when you're designing these new ships that are operating off alternative fuels, do you see a significant demand for energy as a service? So like you were talking about how right now there's no bunkering infrastructure specifically for ships, but hydrogen can be transported to the vessels and they can bunker alongside. So I'm wondering, do you see when you're designing ships, be it for hydrogen, LNG, electric hybrid, that there's a demand from ship owners saying we want new builds or retrofitting our existing vessels and have energy as a service brought alongside to the ships?
Yeah, I mean, that's a complicated one. It is certainly they need to resupply their vessels as simply as possible and as economically as possible. And so it's complicated because the petroleum sector is well developed and it's become quite efficient in how it's transported and stored and distributed. And so that needs to develop, and now we've got all these alternative fuels. So we're trying to, we're talking about 4 or 5 different fuel types, and there's probably no one sector that can put as much investment in which horse do you back is the question right now.
That's true. Yeah, that's good. And I mean, that kind of leads me into the question that, Jason asked me, like, how is BC positioned? Great segue there, Chris, to toss it back over to me. But, I think in terms of leading the way for decarbonization, the countries around the world globally that are interested in promoting decarbonization or promoting even development of their marine and transport industries have prioritized decarbonization as sort of the #1 thing we need to do to get there. And it's unfortunate that Canada as a whole is a little bit behind when it comes to keeping up with other more progressive countries. Norway, we know, has really taken the lead And then the United States, the path that they've chosen, rather than regulating everything, they have decided to just throw money at the situation. And I think with the new 2023 budget, the federal government is definitely looking to do more of that type of work. And I would say that part of BC's advantage is we have a great, ecosystem of innovators, a couple of who are on the call here today, and support for them through like COAST, VMCC, ABCMI, and other industry organizations working in our province to advance and support organizations. We have Foresight, a clean tech accelerator working in this regard as well. And the BC government offers a lot of really great programs to support when it comes to funding opportunities for those organizations. And another advantage we have here in our province, of course, in Canada, is abundant of natural resources. Like, we have great hydroelectric supply here. We have opportunities to produce more hydrogen. We have good LNG supply. I know that's generally an alternative fuel people like to step over, and even, deep sea ship operators like Maersk have chosen to go right to methanol, sort of to force the hand. But the reality is that LNG will be a stepping fuel as part of this, energy transition. So that's definitely still on the table. And of course, methanol or other alternative fuels can be equally as toxic to make. Like, methanol and ammonia don't sound particularly friendly, right? Not to put too fine of a point on it, but when people say ammonia, I'm not jumping up and down and thinking, wow, that sounds really green, right? But we all know to make these different fuels, we need the green processes in place to continue to refine them, right? So, yeah.
So maybe on a follow-up on that one, how much influence can we have on the international shipping market? Obviously, we can have a lot of influence on the domestic and the Canadian fleets, but the international is still, that's governed by their own rules. So I think you mentioned that the US is moving away from maybe almost penalties and moving towards, incentive side of things. Is that a direction that we can possibly take as well with the international community?
Yeah, so the answer to that is really twofold. And one is that, I think Transport Canada, when you look at their green shipping corridor strategy, which is more for the international markets, they've decided to kind of leave it open to allow industry to define what that looks like. So they're really wanting industry to take the lead. And I think in a way that makes sense, because it enables, the deep sea ship owners, and of course the regional ship owners will be affected by what is chosen globally, what alternative fuels become the fuels of choice, because that's where the demand will rise to meet the supply for that particular market. But I think right now they're hoping that industry will take a choice, and then they will continue to support and pursue that and make it more specific in the years ahead. But I think that's where they are right now. And, BC is really perfectly positioned to work with international ship owners. We have a fair number of them with small outpost offices here in Vancouver, or like my own background, working for Seaspan Ship Management for 10 years here in Vancouver. But we oftentimes forget that the Port of Vancouver is North America's third largest port. It sees over, roughly 3,000 vessel visits per year. It is Canada's largest port by magnitude. I think it's like one of every $3 of ocean trade is coming through that port. It's quite high. And they, there's great opportunity through that to work with the international market to decarbonize here in our province.
Thank you. Chris, we got a question from the audience. When's H2 Ocean going to be up and running? And what are the steps that have to go and the challenges you are to get it there?
Oh, okay. Yes. Well, we've been working hard on the design and the regulatory approval process, as we're working with Lloyd's Register and Transport Canada to implement the hydrogen as a marine fuel. And so there's a lot of safety systems, and the rules and regulations around that have not been written. They're in the infancy. So there's been drafts produced, and so we're working through all of that to try to figure out what needs to be done to introduce hydrogen as a marine fuel, and that's been a long and difficult process. But it's a process we need to go through to get to that stage. We hope to start construction in later this year or next year, and then the construction process would be 18 months to 2 years. Of course, this would always be accelerated with the a little more investment. A private investment would move this along faster, as there is a lot of government opportunities for investment, but they're limited as to the percentage of funds you can get from the public sector, government sector. So you know, a private investment would certainly accelerate the whole process.
And there are examples of hydrogen vessels operating today, I believe, is there?
Yes, there are. There's at least a few around the world. We have a relatively local one that was built in Bellingham and is now in San Francisco and is just starting operations there as a ferry and tour vessel. It's somewhat similar to ours, a little more of a ferry than a tour vessel, but it's hoped to be running on a regular basis in the San Francisco harbor in the coming months. And then there's a ferry and a car ferry across one of the fjords in Norway that's running on hydrogen fuel cells. And then Belgium has a hydrogen fuel cell, a hydrogen combustion engine tug operating in Antwerp, or just about to enter operations. It's going through its last stage of commissioning. So there's a few around the world, but there's not really that many. And this would be the first in Canada, which is an important step, is to have a Canadian vessel and go through the domestic requirements for introducing hydrogen as a marine fuel.
And I got another, thanks, Chris, and another question for Elisabeth from the audience. I'm not sure if you can see that, but what's the single largest obstacle? This is a really good question, actually. What's the single largest obstacle that VMC is currently facing? That's going to put you on the spot.
What was it who was facing?
What
the
is
industry?
The VMCC, no, you're the centre, or basically, yeah, your centre's goals to get to net zero. What is your single largest obstacle? Is it lack of industry buy-in, lack of government support, cumbersome regulation, funding, lack of funding, or lack of skilled professionals and labour?
Well, yeah, I mean, that's an interesting question. Like VMCC is a not-for-profit organization, so we're generally a facilitator. We work with industry. So maybe if they're meaning like what are our members' challenges they're facing, I'm guessing. And I would say right now, it's kind of all of the above. It's a bit of a cyclical process. And I hate to give such a vague answer, but it's the reality, that when we're looking to implement these technologies, we're looking at, various different components, some of which you mentioned on there. So like one could be like technical maturity. We talk about using technologies that utilize alternative fuels, and some of the discussion has been around that today. Like we're talking about the energy as service, or Chris mentioning, there's actually a limited number of ships using hydrogen. We tend to talk about hydrogen like I could just walk up to the pump and fuel my ship right now. But the reality is that's just not there. So there's the challenge of, do we have the technology in place to actually make this happen and utilize it? What about the fuel availability? Is it available in the quantity? Chris mentioned that HTEC is ramping up to produce 12 tons of hydrogen. And my thought immediately is, like, how many vessels or how much can that actually fuel, right? What will be the cost of that? How much will that grow? Is that green supply? Is it already spoken for? Is it enough for additional, members in industry wanting to operate assets to use? And then there's that long-term buildup of that infrastructure as well. LNG has been over 20 years and we're still at a limited supply of that in our region. So how much longer will it take for hydrogen to ramp up? And then Chris also mentioned the rules and regulations, and Alistair has been around this cycle as well. So we need safety guidelines for use of these new alternative fuels. We need requirements for onboard and shore-based systems as well. And then the financial barriers as well, the capital expenditure. Oftentimes these green projects, we really want them. We want to decarbonize. Operators want to adopt these technologies, but they can be 2, 3, 5 times the cost of them just implementing a normal carbon-based technology on board. And likewise, last of all, one thing we don't often think about, but is the volumetric density of these new alternative fuels and energy. So we have infrastructure in place, to fuel diesel, HFO, all these sorts of things we're currently using. But I don't know specifically what it is, but like hydrogen might be like 2, 3 to 1 compared to that. So if we're looking at shoreside infrastructure to hold those types of fuels, how much land is that taking? How much is that going to cost, especially in a port like Vancouver, where the cost of land is very expensive and already spoken for? Are we taking vessels somewhere else to bunker? What does that look like? Also on board the ships, they have limited space. And for large commercial vessels, they won't want to be sacrificing so much of their space that they're selling to transport goods in order to have these large fuel tanks on board. So what we find generally with our members while we're working through this, it's kind of like a design process. We say, where do they want to go? And we slowly start chipping away at this and try to bring the right players around the table to make this happen. And I would say that VMCC does a good job doing this because we try to bring different players who can help action each of those different areas together for constructive projects and discussions.
If I can, oh, sorry, go on, Jess.
That's all right, Alistair, you go.
Well, I was just going to say that this infrastructure issue is obviously very important and very significant, both in terms of land-based spending and also on-board ship spending. Changing the combustion on a ship is going to cost you, a significant amount, 10 million-ish or something like that. Whereas I have to say wind assist is relatively cheap, and it's a technology which is readily available, it's understood, it has history, and so there's a lower threshold of entry for wind assist than there is for these alternative fuels, and it sits happily with any other sort of combustible. So it's supplemental. There is going to be a basket, and that's the future, investments in wind assist are going to be paying from the get-go with a relatively low capital expenditure in the initial phase, and you can then use the savings to help fund the other developments as an owner.
How much on sort of moving on from that, but how much in new ship building right now is new technologies being adopted into a brand new ship coming out? Alistair, I think you mentioned earlier, before we started the session, that there's over 1,000 ships built a year. Now, I don't know if that's just Maritime.
It's about 1,600. I calculated it 2 ways and got nearly exactly the same figure. It was quite extraordinary. So that's kind of it in terms of, unless you're going to start rebuilding new shipyards, there are kind of limits at the moment in terms of a new build.
So a question for all of you, I mean, especially Chris and Elisabeth as well, about the naval design. I mean, are these new technologies being adopted into those new ships yet, or is there still some work to do? I mean, obviously there's the retrofitting requirements, which is big because there's so many vessels around, but how do we make sure those new ships are being built with these new technologies?
There are a lot of new technologies being implemented on ships, and it's not a simple answer. There's a whole variety of shipping. So there's the deep sea ships, and which none are built in BC. They're all built in Korea, China, Japan. Tends to be where those are built. And but they are implementing a lot of methanol fueled propulsion systems, and there's LNG systems. Electric is being used in short ferries and harbor vessels. So like there's a myriad of technologies being adopted and used, and we're Vancouver is fairly progressive in that area. Elisabeth's former company, C-SPAN, they operate LNG battery vessels that transport the trailers that supply the Vancouver Island with all the goods on a daily basis. And there are new harbor tugs or ship docking tugs that are under construction in Turkey right now for operation on the BC coast coming up in the next couple of years. So there's a lot of exciting stuff, and BC has a lot of expertise, as Elisabeth has mentioned. Many of her members can contribute on an international scale from the new technologies that they produced, and a lot of world-renowned companies. So it's exciting. It's going to be a complicated process to get there, but there's a lot of opportunity for different companies and technologies.
I guess it's almost a new industry, from everything from manufacturing some of these things to incorporating them, designing them. There's a great lot of opportunity for BC, and in fact, I'm just thinking about building sails like the here in BC for the ships, or your boats, Chris. Would be fantastic to have that sort of being built here in BC, and sort of transition that workforce into that clean shipping side of things.
Exactly. Yeah. No, it's an opportunity, and BC being a strong sector, as a strong maritime industry here in BC on the world stage. It's a great opportunity, and all the government support we can get to continue to promote that, and to get more awareness out there, and that we do have such a capable industry, it's exciting, and there's lots of opportunity there.
Our business model is really designed to create a hub, a franchise hub in Vancouver, which would be where we develop everything, the training and the initial installation. But the scale of the implementation is so vast that we'd have to set up franchises all over the world, because our technology is very cheap, cheerful, and simple. But it needs to be trained, and it needs to be delivered. But you can't, as I say, at scale, you can't do it from one company. The numbers are just too massive. So that's our view. And from our point of view, Vancouver would become the knowledge hub of that franchise, establishing and designing and advising, and then training people to install all over the world. The other thing about the disruptive collaboration is that by buying in a lot of stakeholders, which would be the other wind assist device designers, but also the shipping companies, the charterers, and the shippers, the UPS and all the rest of it, is that would then give us access. If they all have a slice of the IP, then they have a vested interest in maybe seconding people or placing people in management positions across their network, across that franchise, so that we'd have an inbuilt naval knowledge base to then transition into running the franchises internationally.
I was just thinking from what you just said there, Alistair, and I hadn't sort of come across that yet, but when you talk about this whole concept of clean shipping, it touches just about everybody. The stakeholders involved right through everything. It's not just shipping. It's not just the ferry services or the shipping or the ship operators or the ship builders, but now you got the end users. And in the end, the end users are the public. Waiting for our goods to arrive. So how do you move forward in getting those stakeholders involved in having these discussions to really push that this is such a priority, and demonstrate how we need to get there, and who do you? I mean, the key partners are things like government and industry, but it's a big table to put together.
The difficulty from our point of view, as I said, we have the paradigm shift, and it is that people are, generally speaking, investors, angel investors, or anybody else is looking at yields or ROIs Currently, yields and ROIs are fundamentally rooted in hydrocarbon energy density and leverage. So if you're then going to try and compare ROIs for non-carbon technology with existing expectations of market yields, then you're missing the point. And that's the problem. That's the huge paradigm shift. That's the problem. And I don't know, for instance, historically, the reason why people get capital allowances and tax write-offs on capital investment is because competing Western European nations were trying to get their private sectors to harmonize with their strategic national goals. And so it's a construct, an artifact, but that's become normal. And at some point you think, well, if you put carbon on company balance sheets, then they would actually not be doing it just because they're innovators or first adopters. They'd be doing it because it's hitting their bottom line. How that's done, I don't know. But at the moment, as I said, the paradigm shift issue is fundamental to a transition to all of these alternative non-hydrocarbon technologies.
We've got a couple of minutes left. Elisabeth, Chris, did you want to add to any of that? No, we're all good. I don't think there's any other questions. I'm tapped out. I appreciate your time. It's been a fantastic discussion. It needs lots more, obviously, but Elisabeth, you're pushing in that direction, which is brilliant. And I wish Chris and Alistair the best in furthering their technology. That's it for today's session. Thank you for Elisabeth Charmley, the co-founder of Vancouver Maritime Centre for Climate, Alistair Johnson for Dasivedo. I almost got there the first time. I will get better. It's the Australian accent in me. Chris Mulder, the president of Capilano Marine. Really appreciate your time, guys. I know you're exceptionally busy, so to take an hour out of your day and provide this, it was great. As always, we'll be putting our Coast Talk up on the website. I encourage people to sign up for our newsletter. Our next Coast Talk is on June 15th. If nothing else, thank you very much for your attendance, and we'll speak to you next time. Thanks, everyone.
Thanks, Jason.
Thank you. Goodbye.
Thank you so much. Yeah, it was a pleasure to
And
be here.
Chris will be in touch.
Absolutely.
Sounds good, Alistair.
Thank you.